Welcome to qnawire.
So now we'll work on problem 18 from chapter 17. In this problem, we're asked to calculate the percent ionization of 0.125 molar lactic acid and the percent ionization of lactic acid in a solution containing 0.0075 molar sodium lactate. So first, let's go ahead and write down the Ka, which we're given for lactic acid, and that's 1.4 times 10 to the minus 4. So since lactic acid is a weak acid, we can write an ice table. So we have our acid reacting with water to produce the conjugate base and hydronium. So we have our initial change in equilibrium. So our initial for the acid is 0.125. We disregard water and no initial base, conjugate base or hydronium, and we subtract x, add x, and add x. So we have 0.125 minus x plus x, just x. So we have 1.4 times 10 to the minus 4 is equal to x squared divided by 0.125 minus x. And since it's a weak acid, we can disregard this minus x here. And we get x is equal to 4.18 times 10 to the minus 3. And that's the concentration of hydronium or conjugate base in the solution. And so to calculate the percent ionization, we divide this 4.18 times 10 to the minus 3 by our initial concentration, which is 0.125, and then we multiply by 100, and we get a value of 3.35% ionization. In part B, we're asked to do the same thing when we have a solution of lactic acid, solution of sodium lactate. So we can use the same expression, which is Ka is equal to 1.4 times 10 to the minus 4. So the only difference now is that in this area here, we're adding in a concentration. So we can just add that to our expression. So instead of being x squared, it will now be this concentration of sodium lactate plus x times x, and then we divide by 0.125 minus x. We cancel these two here because we're working with a weak acid, and we get a value, or we can get x is equal to 2.33 times 10 to the minus 3. And so if we do the percent ionization the same way as we did before, we get 2.33 times 10 to the minus 3 divided by our initial concentration, which was 0.125. We multiply by 100, and we get a value of 1.87% ionization.